Welcome back to your College Algebra lecture notes. Today we're going to be looking at section 3.5, transformations of functions. These are a lot like composition of functions, just different things that we can do to functions, to adjust them, to change them, to transform them. So let's jump right in and get started. Today, scripture of the day is going to feel a little more on the nose, and that's okay. But as we talk about transformations of functions, it doesn't have a lot to do with the functions themselves, but Romans 12:2 says, "Do not conform to the pattern of this world, but be transformed by the renewing of your mind, and only then will you be able to test and approve what is God's will, the good and pleasing and perfect will." And so this is talking about his repentance, or a change of mind, the way that we view God and our relationship to him after becoming Christians, after being born again, and the way that our mind's being changed by God and for God. So as we talk about some less important transformations, I think it's probably a good thing to think about the most important transformation that could happen, which is turning your life towards God and seeking him through Jesus and the Holy Spirit. All right, let's jump right in. So transformations of functions. We're going to start with the easiest one of all four, which is the vertical shift, where if you see this plus k over here on the outside of the function, then it just goes up by k. And if you saw minus k, so for example, I'll do it in a different color. If you saw f of x minus 1 on the outside of the function, it would just shift down by 1. So the plus k on the outside is up, and a minus k on the outside would be down. Pretty straightforward. So here's an example. It's a word problem. It talks about there's a function that they give you. It's thrown upwards, but suppose instead of throwing it upwards, you threw it from the top of a 10-meter building. So you started right here, and you threw a ball, and it did a parabola, an upside-down parabola. And it said, suppose instead you stood on top of a building and you threw the same ball. Well, which way is that shift happening if you take that starting point? It looks like the shift went up by 10, and so we're literally just going to write the exact same function, but on the very outside of the function, we're going to add our vertical shift. And did we go up or down? We went up, and so we write plus 10. And maybe instead of calling that h, we can call that g, because it's a new function. It's a new function that was h of t plus 10. So we just took the exact function they gave us and said shift it up by 10. So this goes up by 10, which means you got to do a plus 10 outside of your function. Cool. Horizontal shift. Pretty similar, the plus and the minus, except you'll notice now it's on the inside, and it does the opposite of what you might expect. So if you have a negative h or a minus x minus h on the inside, it's actually going to go to the right. And then like in this picture, if you have a plus on the inside, it's going to go to the left. And so the way I like to think about these, because it's the same for transformations, for shifts, for horizontal shift, vertical shift, but also for stretches and compresses, when it's on the outside, it kind of does what you expect. Plus 1 goes up 1. Times 2 is twice as tall, or it's a vertical stretch by a factor of 2. But when it's on the inside of the function, it does the opposite of what you would expect. And so plus 1 on the inside doesn't send it to the right, but it sends it to the left. And times 2 on the inside would actually make it smaller, or horizontally compress it by a factor of 2. And so the way to think about this is when it's on the outside, it does what you'd expect. And when it's on the inside, it kind of does the opposite of what you'd expect. So here's a function, and they're going to ask us just to graph the shift. And so we need to graph the original function, which means you need to have your toolkit functions from section 3.1 memorized. If you don't have them memorized, there's a table there to help you. Like, for example, if you plug in 0, you get 0. And if you plug in 1, you get 1. And if you plug in 4, you get 2. This is for f of x. But it's really, really important that you go back and look at those toolkit functions and memorize them. And so there's my function, f of x equals the square root of x. But it's asking us to do something to this function. It's asking us to shift it to the left by 2. Remember, it's going the opposite direction you might think. You might think plus would send it to the right, but it actually doesn't. It sends it to the left. And so I'm just going to take each of those nice, neat points and shift them over by 2. Notice how we just went to the left by 2, and then I'll draw my shape. And that blue is f of x equals root x plus 2. And that's a horizontal shift to the left by 2. If you wanted to plug and chug some points, f of x plus 2, you could. So if you plug in 0, you get the square root of 2, which isn't as helpful for graphing. But if you plug in, let's say, -2, then you get 0, which looks like a point on our graph. And if you plug in, let's say, -1, you get 1, which is a point on our graph. And so the horizontal shift sends it to the left or the right. Here's a function where they're going to do both of them, a horizontal shift and a vertical shift in the same line. You don't have to pick one or the other. You can do either one first. I would recommend doing the horizontal first because it's on the inside of parentheses because PEMDAS, but that's just me. And so the two shifts here, well, first we need to graph the toolkit function, which I'll do in blue. The toolkit function is the absolute value function, which if you remember looks just like this. The perfect line, but reflected on the left side or the negative side. Looks like a V kind of. And then what we're going to do with this absolute value function is we're going to shift it to the right by 2 because of this red shift right here, the -2 on the inside. And we're going to shift it up by 4 because of this blue plus 4. So hopefully you're seeing the pattern and we're doing the same thing. And so I'm not going to graph the whole function. I'm just going to graph a few points of it so I can get an idea. But I'll go over by 2, to the right by 2, to the right by 2. And there is my first transformation happening. Notice how I went to the right by 2. But then I need to go up by 4. And I probably should have made that a different color because we started with the blue function. So let's make it green. Up by 4 is now green, which means we go up by 4 with the green graph. And so all of my green points are going to be 1, 2, 3, 4, up by 4, up by 4, up by 4, and I'll draw some lines connecting those points since this is my final equation, or my final graph. So it looks a little like that, and it looks a little like is that a good line right there? That is pretty good. And so the final function was f of x minus 2 plus 4, which if I wanted to write this as the absolute value, would be the absolute value of x minus 2 on the inside plus 4 on the outside. And it's that green function. Notice that outside, inside meant outside the absolute value and inside the absolute value. Here we have them asking us just to write to kind of see a difference in outside and inside. So if we start with f of x equals 1 over x, and we need to shift it 1 unit to the right. So to the right means minus 1 inside, and 1 unit up means plus 1 outside. And so g of x, my transformation if we want to call it, will be, well, there's no real inside because there's no square root or absolute value. Inside means inside what the function's doing. And so our inside, quote unquote, is going to be on the bottom of the rational function. And so we'll have x minus 1 being our horizontal shift, unit to the right, and plus 1 being our vertical shift. And there's a function. That's the reciprocal function, which also was on the toolkit functions, shifted 1 unit to the right and 1 unit up. All right, let's move to our second type of transformation. So that's shifts, horizontal and vertical shifts. Our second type is a reflection, where we take a function and either reflect it across the x-axis or reflect it across the y-axis. the vertical reflection is a negative on the outside, and it kind of just looks like this. If you're looking down, like if you're standing on a puddle and looking down. The horizontal reflection is a negative on the inside, and it kind of looks like you're looking in a mirror standing up, like a barn door reflection. And so what we're going to do is graph a function. Notice it's an interesting function. It's an already shifted function. So it's the absolute value function, which looks like the v, and it's been shifted how far, if you want to think with before I say it, to the right by 1. And so I'm going to start with my function of the absolute value to the right by 1. So it should look like that. That's just the normal absolute value function. Up 1 over 1, 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 but shifted to the right by 1 to start. And then to reflect it vertically, we imagine that it's standing just looking down on, like imagine there's a mirror on the ground and you're standing and looking at it. If you've ever seen the Washington Monument, it's kind of like that's the idea that we're going for. And so we just reflect it vertically. Be careful as you draw your lines that you pass through all the good points. And put some arrows on it so we know it goes on forever. And that function right there would be reflected vertically, which would just be f of x, we'll call it g of x equals negative x minus 1 because the negative went on the outside. And that black function originally was f of x equals negative x minus 1. All right. Now we want to take the same type of function. So actually I might copy and paste this because we're going to start with the exact same function. Bring this over here. Say put it at 1, 0 to start. Awesome. Where did that negative come from? I didn't mean to write that negative up there. Thank you. 1, 0 to start. And now we're going to shift it horizontally, or reflect it horizontally. So that means I'm just going to flip it across the x-axis. And so any point, so this is 3 away right here, and so it better be 3 away over here. And this is 4 away, so it better be 4 away. And basically I'm taking every point and mirroring it across the x-axis to draw a new blue absolute value function graph. So it looks a little bit like that. Put some arrows on it so that you know it goes on forever. And then we call the last one g of x. So we'll call this blue function h of x. And we'll say, what was the rule for the horizontal function? Well, it was to put the negative sign inside of the function. So I'll put a negative sign on the inside next to the x, immediately next to the x, and I'll still shift it to the right by 1. Because that's where we started. We started to the right by 1, we leave it to the right by 1. The negative is going to take care of moving it, and it actually kind of looks like it went to the left, but that's because that negative sign is going to also change that negative 1 to a positive 1. Cool. And if you wanted to plug and chug a couple points to check, you could. You're not required to at this point, but like if we wanted to plug in, say, h of 0, that would be negative 0 minus 1, which would be the absolute value of negative 1, which would just be 1. And you can see the point 0, 1 on the blue graph. So if you wanted to, after trying this, plug and chug some points and see if it works. So that's reflections, horizontal and vertical reflections. The negative goes on the outside for the vertical and on the inside for the horizontal, just like the shifts. All right, here's a table, and they're going to ask us just to change one thing, which is add a negative. So if g of x is f of x but negative, that means it's literally going to look exactly like f of x did. So here's the f of x line. They're just asking us to make it negative now. And so negative 5, negative 10, negative 15, and negative 20. And then the question to you would be, what type of reflection is that? A vertical. Next one is a little trickier to think of. And it's got a negative sign on the inside, right there. And so it's a horizontal reflection. So that says what used to be negative is now positive. And what used to be a positive input is now a negative input. So for example, if I wanted to say f, so for this one right here, I wanted to say f of negative 2. Well, that's just the same thing as f of 2. And if I go up to my graph, f of 2 was 15. So notice how I added the negative sign from the purple highlight up here, but I also added the negative sign from the input. And so it's f of negative 2 is the same thing as f of 2, so I go to my original chart and look for that. So then what about for this one? F of negative 0, well, that's just the same thing as f of 0, and so the horizontal reflection actually doesn't do anything at the 0 point. So that'd be 10 from the original chart up here. Then what about f of negative 2? The negative came from the highlighted negative of the horizontal reflection. And I go back up to my chart and I say, well, that's just 5. And lastly, f of negative 4. We'll go back up to that chart and look for what is f of negative 4? Not f of 4, but f of negative 4 in the original chart. We actually don't know. And we can't answer that question. The table did not give it to us. And that's okay. We'll tell them we know these 3 on the horizontal reflection and we don't know the last one because they didn't give us a point for the horizontal reflection of negative 4. You could probably guess and assume looking at that pattern or that trajectory, 15, 10, 5, feels like the next number is 0, but we're not going to assume that if they didn't give it to us, we're not going to assume that we know it. All right, this next one is just, again, I'm going to leave you to try it because it is nothing new. It's the vertical reflection and the horizontal reflection. So try this one on your own, remembering that this f of x is a toolkit function from 3.1. If you don't have those in your brain, if you don't have those memorized and you know what they look like and you know how to graph them and you know how to plug and chug points to get them, then really go and review 3.1 and look at that last page. The toolkit functions you need to know, also sometimes called the parrot functions, are really important for the entire rest of the year. So I'll leave you to try this one on your own because we've already done it with the absolute value function. Now we're just doing it with what's called a parabola or a quadratic function. Something that comes along with these reflections is this idea of even and odd functions. Even and odd functions come from the input and the output. So look, here the input has been negatived, or a negative sign has been introduced to the input, and here a negative sign has been introduced to the output. And based on what happens when you do that, you can say something's even or odd. And so, for example, this function right here, we're going to try both of them and just see what's true. So first I'm going to put it on the inside to check for even. So here's my check for even. And I'm going to say, what is f of negative s? And f of negative s just means I plug in negative s everywhere I saw s before. So f of negative s is just plugging in negative s. And here's the really interesting thing. A negative times a negative times a negative times a negative for this first term is always positive. Because a negative to an even power is positive. Because the negatives will cancel, and then they'll cancel again for the second set. So this is just the same thing as s4. And a negative times a negative on the second term is the same thing as s2, or s to the second power. And we're left with, this is our function for f of negative s. And what you notice is, that's exactly the same thing as f of s in the first place from the original problem. And so this function is even. If you check for odd, you'll see that it can't be even and odd. And so if you try to plug in, what you would do is you would check f of s and put a negative in front of it and see what happens when you distribute that negative sign across all the terms. And so because it's even, from this definition, we know that it's symmetric about the y. Symmetry about y-axis, which is just a cool fact about the graph. More specifically, that looks like a quadratic function, but a little wider because it's to the fourth power, and it's symmetric about the y, so it probably looks something a little bit like this if you look at it on a graph. All right, the last one for today is they've given us some functions and they want us to tell us, or they've given us a graph and they want us to tell them the function. Here's where the toolkit functions that you need to know are really important, because if you don't recognize that graph as one of those toolkit functions, then it's going to be really hard to know where to start. So the parent or the toolkit, those words are kind of interchangeable, is y equals x squared. And if you plug and chug points into y equals x squared, so here's the parent in purple. We'll make this a purple function. 0 to the second power is 0. 1 to the second power is 1. 2 to the second power is 4. And then they mirror across, because it's an even function, look at that power. They mirror across the y-axis. And we get ourselves a parabola, or a quadratic function. And so now we're just asking, well, what have they done to this function? It looks like they've shifted it to the right by 1 and down by 3. But let's check all the points to be safe. To the right by 1, down by 3. That looks good. To the right by 1, down by 3. That looks good. I do think they shifted it to the right by 1 and down by 3. And so our job is to say, okay, I'm going to call it h of x, just so we don't call it f of x. I'm going to say, what did they do to x squared? Well, right by 1 goes on the inside, and so I'm going to say x minus 1 on the inside. Remember, it's opposite of what you would think. Minus 1 means right, plus 1 means left. Squared, and then down 3 is going to be a minus 3. And there's the function that they asked us for. Change those to red so you can kind of see where those to the right by 1s came from, and then change that to green so you can see where the down by 3s came from. And where did the purple came from? It came from the toolkit parent function that we said is really important in section 3.1 to memorize. And there's the transformations of functions. If you look in your textbook, you might see a couple other transformations, namely the horizontal compression and the vertical compression and stretch. Those are important, but when you move on in your math career, we get to pre-calculus, we're going to really emphasize those more. So you might see them in your textbook here, and you might even see a problem or two pop up. Just know they're good to do and they're good to study, and I would encourage you to read through it, but know that that's not the primary focus of this section for college algebra this year. The primary focus is those 4 transformations we did today, which were vertical and horizontal shift and vertical and horizontal reflection. All right, thank you for watching. Again, I would encourage you to watch through these videos, practice the try-its in your blank notes, read through the completed notes, and ask your instructor if you have any questions at all. Thanks for watching. I'll see you next time.